going to take what we've learned about inequalities yesterday and we're going to work on them in the ready books, okay? This is going to seem like a lot of work, but it's really not, because as you know, the ready book gives us a lot of different ways to look at the problems. So we're going to just start off by looking at models, using the graphs, how we can write the inequalities, and basically it's a lot easier than it looks, okay? So don't be overwhelmed by how long this is. All right, so let's get started. To begin, we have this great little table. I probably should have given you this table yesterday when we first started inequalities, because it pretty much sums everything up really nicely. We already learned what an inequality was yesterday, okay? It's different than an equation because an equation only has one solution. When you have an inequality, there's really an infinite number of solutions that make it true. So if we have something such as x is greater than 5, there's not just one solution to that. Any number that's greater than 5 is a solution. So there's an infinite number of numbers that are greater than 5, so there's an infinite number of solutions, okay? So this little table is really handy, I think. If you guys printed out these notes, this is great to have, okay? So we know that this greater than symbol means that there's some keywords here: more than, greater than, above, okay? And it looks like this: x is greater than. Remember the trick I showed you guys in class a while back? If you extend your symbol, you should be able to make a circle, like a bubble, like someone's talking. You should be able to circle the number that's larger, okay, if you have a hard time with this. The other way, of course, is to make sure when you trace it, if it makes an L. So when you write this yourself, that's not an L, that's a backwards L. So that's not less than, okay? Greater than or equal to, at least, that's when you have to try to think of. No less than, another one, and minimum. Those are all greater than or equal to. Less than, again, the trick is, of course, to write the symbol. If you're making it L, that's basically slanted, it's less than. You can also try the circling trick. The number that you circle is the larger one. So x is not circled, so that means x is less than 5. Below is another keyword here. And then, of course, we have the less than or equal to. We have at most, that's used very, very often. No more than, also used very often. No greater than, and maximum. Okay, maximum is also pretty common. All right, so this is a great table. If I were you guys, if you don't have it printed out, I would consider printing it out and putting it in your notes. Okay, guys, so I just thought I was recording this problem and I was not. So anyway, if you look at this, what we're doing is we're trying to represent, using an inequality, what temperatures a heater is going to turn on if it turns on when the temperature goes below 15. We don't have to write all of the temperatures. We don't have to write 14 degrees, 13 degrees. There's an infinite number of temperatures that it could turn on for. So instead, we write an inequality to represent all of those possibilities. So if it's below 15, it's got to be x is less than 15, not less than or equal to, because then that would mean that it turns on when it's 15 degrees also. So x is less than 15 is the solution. To graph it like we did yesterday, x is less than 15. Very helpful how they wrote this out for us. Remember, you look at your symbol, it's an L, so that helps us remember the less than. But also remember, you can draw the little line there and it shows you which direction your arrow should be pointing in. And if there's no or equal to underneath, your circle is an open circle because 15 is not included in the solution set. So you can't darken it in there, because then if you do, you're saying 15 is part of the solutions, but it's not, okay? So your graph would be an open circle and the arrow going to the left. One thing we did not do yesterday is substitute values to check your solution, okay? So, for example, on that graph that we just looked at, -5 is shown as a solution. To check, all you do is replace the x with the number you're checking, okay? So -5 is less than 15 is true. You can show that something else is not a solution. So you can look on that graph and see the numbers that are out of the solution set. In other words, they're not covered by the arrow. So 16, for example, you check it. 16 is less than 15. That's false, so you can tell that you did this correctly. Okay, so let's get into some actual work here. we're gonna look at a graph today and say what the inequality is instead of doing what we did yesterday. So first things first, what kind of a circle do I have? I've got a closed circle. So that means whether this is less than or greater than, it's gonna have the or equal to sign, okay? The closed circle means it's included. Now look at which direction your arrow's pointing in. It's going this way, right? So that's greater than. So I know that this is gonna be a greater than or equal to symbol, okay? So this is x is greater than or equal to, and now we just have to figure out what number is here, okay? So what number is, and of course I have to give you one of these, what number is halfway in between -4 and -5? Well, that's -4.5, and I'm gonna write it as a decimal, -4.5, okay? Most important part here is that you can look at this graph and decide what kind of a symbol it is, okay, in which direction it's going in. We're gonna keep going on to the next section of more inequalities. This problem here, Cooper spent at least $25. You have to think about these problems as though you're actually there, right? At least $25, that means $25 is the smallest amount that he can have spent. That means that he may have spent even more than that, right? So that's where we're gonna get this greater than or equal to symbol, okay? It could be as small as $26, or it could have been as big as $100. Try when you have these real world problems to put yourself in a situation and imagine what the keyword means, because it can be hard. Once you've figured out what your inequality is, you can graph it, and then that's another way to solve the problem. So if we said that Cooper was spending at least $25, we knew that x was greater than or equal to 25. So you go over here, make your closed circle because of the or equal to, and the greater than symbol means it's pointing to the right. These are all possible values of how much he spent at the concert. Again, you can check, you can substitute values in. Something as simple as just 50 cents more, you can see is a possible solution by replacing it with x. So $25.50 is indeed greater than or equal, to 25. The graph shows that $30 is a possible solution. We can check that as well. They just swapped it around. They said 25 is less than or equal to x to show you that it works both ways. And that holds true also. Okay, so they're all about the fractions and decimals today, but we're gonna try what you just learned about writing and graphing inequalities to solve this problem. Some sources say that the Earth's atmosphere does not exist above 30.5 kilometers. Write an inequality to represent where the atmosphere exists. So they're saying it doesn't exist above 30.5. So it must exist below 30.5, right? Do you think that the 30.5 is included? They're saying it doesn't exist above 30.5. So 30.5 can be where the atmosphere exists. So that means it's going to be included. So now we just have to figure out what symbol to use here. Before anything else, I'm gonna go look down here. I've got 30. Notice this jumps to 32. So this little line here is not 30.5, it's 31. So 30.5 is gonna be in between 30 and 31. Okay, so I'm gonna draw my circle here first, okay? So if the atmosphere is below or equal to this amount, that means it's gonna be less than or equal to, okay? So x is less than or equal to 30.5. So what kind of a circle am I gonna have here? It's gonna be closed, and this is a less than symbol, so it goes to the left. You can always use that little arrow trick, okay? And that would be a little inequality graph to represent where the Earth's atmosphere exists. Okay guys, for number 15, I would like for you to try this one on your own. So I'm gonna do what we did, I think we did it yesterday, and everything's blurring together at this point. I'm gonna have you pause this video, and you are going to try to figure this out yourself. We're trying to see which one of these numbers is a solution. So you're gonna basically plug each one in and see which one actually works, okay? So go ahead and give that a shot, and then when you're done, you can unpause and you can see the right answer. Okay guys, so here's the solution here. Which of these values is a solution? So when you plug in 4 here, you'll see that 12.6 is less than or equal to 12, and that's not true. When you plug in 4.2, you see that 12.6 is less than or equal to 12.6. So because of the or equal to, that is true, so that's a solution. When you plug in 3, you get 12.6 is less than or equal to 9, which is not true. I forgot to put my little X. And then when you plug in 10, you get that 12.6 is less than or equal to 30, which is true. So you've got 2 possible solutions here. Okay. Number 16, algae cannot survive at depths greater than 300 meters below sea level. They're giving us the inequality here. So in order for the algae to survive, it has to be at less than negative 300 meters. So they want us to graph this. So x is less than negative 300, okay? So of course this is a less than symbol. There's no or equal to. So we're gonna find our negative 300 and we're gonna draw a nice open circle there. And then we see it's less than, which is left, okay? And if you draw your little line, you can see which way your arrow should go. And there you go. There's your graph. Okay, and now for our final question. Which inequality represents the situation? Haley has, at most, $500 in her bank account. Remember, this is one of those cases where you want to put yourself in a situation. Imagine that it's your bank account and you're saying that you have at most $500. What does that mean? That means that the largest amount you could have in your bank account is $500, which means it can't be any bigger than that. So the 500 is the largest number. So the amount that you have in your bank account has to be less than that, but it could also be equal to that. So it's going to be x is less than or equal to 500. That's choice D. Now Tessa chose C as the correct answer. How did she get that answer? Let's think about it. She chose the one that was only less than. When it says at most, that means that the number is also possibly included, like we just talked through. So what Tessa did was she read this in her head. She thought of it as Haley has less than $500 in her bank account. So try to remember the difference. If you rush through it, there's a chance you might make the same mistake as Tessa. So make sure you put yourself in a situation. Okay, I'm going to have you guys answer this on your own. You can use what I just said to come up with your answer, but it's basically the same gist. Okay, so that's everything. I believe I gave you guys independent practice today in the book to practice, and then you have some homework to do. Please keep in mind, guys, if the amount of work is a little bit too much, because I understand that you guys have work for every class, you can be honest with me and let me know that. This is a crazy tough time that we're all going through, so you know, we're all flexible. So just let me know if anything gets to be too much. And if it's a good amount, then let's just keep doing what we're doing. Okay, guys. Have fun doing your favorite subject, math. All right, just kidding. Okay, see you tomorrow.